All right, today we are actually finally starting Module 4. We are finished with Module 3, but Module 4 is it's still trig stuff, okay? It's just a new module. So what we're learning about today is called the Pythagorean Identity. Do y'all remember Pythagorean theorem from geometry? Can anybody tell me when you used the Pythagorean theorem? Just hypotenuse? Yeah, any side of a right triangle, right? If you knew two sides, you could find the missing side. So what we're doing today is called the Pythagorean Identity, which is very similar. And our target describe the Pythagorean identity how is it useful and be able to use it correctly. All right, so I'm going to start by drawing a unit circle that we've done 1,000 times. And I'm just going to draw a random triangle in that first quadrant. And we know where that radius, technically, that I just drew from the origin, has an ordered pair of x, comma, y, right? Your x is the distance from 0 to the end of that triangle on the x-axis. Your y is the distance from where that little line segment on x-axis and then where it met up with a circle. So basically that's the length of the line, the part of the triangle that is parallel to the y-axis, right? That's where you get that ordered pair from. And then we know in a unit circle, the hypotenuse always has a length of what? 1. So we know that the Pythagorean theorem, usually we say a squared plus b squared equals c squared, right? We label our legs a and b, and c would be the hypotenuse. But in trig, what we've been using instead of side a and side b, we have side x and side y, right? So would you agree that the way we have this labeled, that's the same thing as x squared plus y squared equals 1? The way we have that labeled, okay? Well, for Pythagorean identity, obviously comes from the Pythagorean theorem, but instead of x, what do we call x in trig? Cosine. So instead of x squared, we say cosine squared of theta. And what do we say instead of y? Sine. So instead of y, we're going to say plus. Instead of y squared, we're going to replace that with sine squared of theta. And in a unit circle, the hypotenuse is always 1. 1 squared is 1, correct? So this is the Pythagorean identity. We get it from the Pythagorean theorem. Unit circle, your hypotenuse is always 1. So this is Pythagorean theorem. Your any old triangle doesn't always have a hypotenuse of 1, but in unit circle it does. So what the Pythagorean identity is good for is if I just know the cosine of theta, I can use the Pythagorean identity to find the sine of theta. Or if I just know the sine of theta, I can use the Pythagorean identity to find the cosine of theta, okay? Now, we know, like, well, most of these we could just find easier, but just using the unit circle, right? But does the unit circle have every single possible angle measure on it? No. If I said, hey, your angle measure is 38 degrees, from what we know about the unit circle, is 38 degrees going to be in a special right triangle? No. So what we're getting into now is, okay, well, how do I find these things when they're not on the unit circle? Okay. So of course you know I'm going to write that in the notes because that's how I roll. The Pythagorean identity is useful because if you know sine of theta, you can find cosine of theta, in parentheses, I'm going to say or vice versa, using the Pythagorean identity. So the first example that I'm going to give you, we're going to do one of a problem that we already know, so that way we can like see how it really works on an answer that we would already know without using the Pythagorean identity, just so we can prove, I can prove to you that it will work. Okay. Anybody have a question so far? All right. Example 1. Given that theta is between negative 3 pi over 2 and negative pi. So that's basically telling us what quadrant we're going to be in, right? And sine of theta is equal to 1/2. Find the tangent of theta. Okay, well, I just said it was good for finding sine and cosine, right? Well, don't you need to know the sine and cosine to be able to find tangent? Okay, so they told us the sine's 1/2. We need to find cosine before we can find tangent. And we're going to do it using the Pythagorean identity. I know that this is probably the most difficult way to answer this question, but like I said, I'm just showing you how to use the Pythagorean identity. All right, so they're telling us that our theta is between negative 3/2 pi and negative pi. So are we going counterclockwise or clockwise around our unit circle? Counterclockwise because it's negative angle measures, right? So let me first figure out what angle or what quadrant I'm in. So if I start at 0, clockwise 90 degrees would be negative pi halves. Clockwise 180 degrees would be negative pi. Clockwise negative 270 degrees would be negative 3 pi over 2. And clockwise 360 degrees would be negative 2 pi. So what quadrant is the sine of theta in? Quadrant, what? 2, quadrant 2, because that's between negative pi and negative 3/2 pi, right? So somewhere in this quadrant, and is it, I know sine, is that your x value or your y value? Y. So I know the y value, I need to find the x value. All right. Now, is my x value in this quadrant going to be positive or negative? We know it's going to be negative, right? So just keep that in mind, because obviously the sign's going to make a difference. Do we already know what it's going to be? What? Negative square root of 3/2, right? But we're going to pretend we don't. We're going to use the Pythagorean identity, which is cosine squared of theta plus sine squared of theta equals 1. We don't know the cosine, so I'm just going to bring cosine squared of theta down, and I'm going to add the sine, which is 1/2, but in this formula, that's squared, right? Don't forget to square it or we'll mess your whole problem up. All right, so let's solve this. Cosine squared of theta, I don't know. Bring it down. Nothing to do there. Now, 1/2 squared, doesn't that mean 1/2 times 1/2? And what is 1/2 times 1/2? 1/4. And that equals 1. What do you think we're going to do now? Subtract 1/4 from both sides. So on the left side, cosine squared of theta is all we have. 1/4 minus 1/4 is 0. On the right side, what is 1 whole cup of sugar minus 1/4 cup of sugar? 3/4 cups of sugar. Now we know that's not my cosine. What's the problem? What have I not done yet? What do you think I should do? What? Square root. Because I don't know the cosine of theta. I know cosine squared of theta. So yes, I will have to take the square root of both sides. And remember, when you take the square root, squared means 2. 2 is an even number. When you take an even root, your result can be positive or negative. We're going to take the square root of 3/4. And I don't want a decimal. I want an exact value. So I'm not going to put this in my calculator at 0.75 square root. I'm not going to do that. I'm going to do the math on a fraction. But first of all, what's the square root of cosine squared of theta? Just cosine of theta equals the positive negative. Now, when you have a fraction, you can take the square root of the numerator separate from the denominator. So I like to write it in 2 separate parts, like the square root of 3 over the square root of 4. What's the square root of 4? 2, without a radical, right? Square root of 4 is 2, not square root of 2. Is 3 a perfect square? Does it have any perfect square factors other than 1? No, so we'll just leave it square root of 3 over 2. And that is positive or negative. However, we're in quadrant 2, where my cosines are negative, right? So we're not going to take the positive square root of 3 over 2. We're going to take the negative square root of 3 over 2. Might want to make a note. Take the negative root only because our angle is in quadrant 3. So great, we found the cosine, but is that, yes? 2, sorry, quadrant 2, not quadrant 3. Thank you. Quadrant 2. So yeah, we found cosine of theta. However, our question asks us to find tangent. We have to know sine and cosine to be able to find tangent, right? So we had to find that first in order to be able to find tangent. Now, are we going to need the Pythagorean identity to find tangent? No, we just had to do it to find. I know really we didn't even have to do that, but again, I'm just showing us an example on a problem that we already know the answer to. So now, find tangent of theta using sine of theta divided by cosine of theta. So sine of theta was 1/2 divided by cosine of theta was square root of 3/2. We know we have a complex fraction here. We know how to simplify it. What would I do? It is, good gracious, negative square root of 3/2. Thank you, because that would make a difference in my answer, of course. What would I need to do to simplify this? Yeah, so first let's get rid of the fractions within the fractions. That's a complex fraction. Multiplying by the least common denominator, which is 2. Fortunately, at both of them, they cancel, right? So we have, in the numerator, all we have is 1 over negative square root of 3. Is that going to work as my answer? No, why? Or exactly, I can't have a negative in the denominator, so there's one problem, and you don't want to leave radicals in the denominator. That's 2 problems. So we have to rationalize it. So I already know the negative is going to be moved to the numerator, so I know that. But how can I get rid of the square root of 3 over the square root of 3? Over, right. So multiply by the square root of 3 over the square root of 3 equals, let me move that negative to the numerator, or you can write it right next to the fraction bar, either way. 1 times the square root of 3 is the square root of 3. The square root of 3 times the square root of 3 in the denominator is the square root of 9, which is 3. Can I reduce the 3 under the radical with the 3 in the denominator? No. That's my answer. Anybody have a question so far? All right, so now let me give you one. I'm going to give you a sign that we're not familiar with. And we're going to find the cosine. On this first one, I ask you to find tangent. On this next one, I'm just asking you to find a cosine. So you just have to read the directions of each one, like what am I finding? Just the cosine, or just the sine, or they ask me to find tangent, or whatever it is. Cool beans? Example 2. Given sine at theta equals negative 24 over 25. So what quadrants is this going to be in? You have 2 choices. If your sine's negative. 3 or 4, right? 3 or 4, they both have a negative theta, or negative sine. Find cosine of theta when theta is located in quadrant 4. So they're telling me it is in quadrant 4, which we knew it had to be 3 or 4. I know it's going to be in quadrant 4, and I know sine is negative 24/25. I need to find my cosine. A pretty sad looking circle I drew there. And my cosine in quadrant 4 going to be positive or negative? Positive. So just make sure when you give me your answer is a positive number. All right, so they've given us sine. We have to find cosine. We can use the Pythagorean identity for that, which is sine squared of theta plus cosine squared of theta equals 1. On the last one, I think I wrote cosine squared of theta plus sine squared of theta. Is that going to make a difference which one I write first? No, it doesn't matter. You're adding them together. So I know my sine is negative 24/25, and I've got to square it. That's where usually that's where the kids mess up, is they forget to square it. Plus cosine squared of theta equals 1. Everybody close so far? So first of all, when I square this fraction, is it going to be positive or negative? Positive, because a negative times a negative is a positive, right? So we have to square negative 24/25 times negative 4/25. Or what's 24 squared? I know a lot of y'all got a calculator on your desk. What? 576 over what is 25 squared? 625. And again, I'm going to want an exact answer, so don't turn it to a decimal. So we add cosine squared of theta, and that equals 1. Now what? Right, subtract 576 over 625 from both sides. It turned positive. So we know those two fractions on the left cancel. We're left with cosine squared of theta equals 1 minus 576 over 625. All right, so we're going to need to do the math. What is 1 if I want to make it a fraction? Okay, so 1 over 1 minus 576 over 625. Can I subtract them the way they are? No, because you have to have a common denominator, which is going to be what? 625. So the bottom denominator did not change. 625 is still 625, so I know the numerator will still be minus 576. What would that top fraction be if it was equivalent to 1? Right, 625 over 625 reduces to 1, right? Or you could say 1 times what is 625? 625. So I would have to multiply the numerator by the same thing. So what is 625 minus 576? 49 over 625. And I don't believe I can reduce those, but I'm also thinking ahead and knowing that I have to take the square root. I know 49 is a perfect square. Is 625 a perfect square? It is. I just did it in the calculator. So even if I could reduce them, I'm not going to, because those are both perfect squares. But I don't think that you can reduce them anyway. All right, is that my answer? No, what do I have to do? Square root. Oh, I forgot my theta. Square root of the cosine squared of theta, and the positive and negative square root of 49 625. All right, the square root of cosine squared of theta is cosine equals positive negative. What's the square root of 49? 7. What's the square root of 625? 25. But is that what I'm going to say? My answer is positive negative 7/25? No, which one? It's got it one or the other. Positive. So my answer is positive 7/25. Make yourself a little note if you're going to forget why I chose positive and not positive and negative. Julio? You have a question? All right, example 3. You want to try this one on your own? Okay. Theta is located in quadrant 3. And cosine of theta equals negative 3/5. Find sine of theta. Did y'all get the same thing I did? -4/5? And of course we chose the -4/5 because it was in quadrant 3, yes? Okay. Anybody have questions about that one? Are you sure? All right, I'll have you do the next one on your own. Example 4. Given cosine of theta equals -12/15 and theta is located in quadrant 2, find sine at theta. So did y'all get positive 9/15? Yay. And positive because sine in quadrant 2 is positive, right? Anybody have questions on that one? All right, I'm gonna have you do one more. This one's gonna be a tangent. Okay, so you don't just stop at finding sine or cosine, and you gotta find tangent like the first example. And then we'll be done, and I'm not giving you an assignment today. Mostly because I looked on Schoology and I got a bunch of work I gotta catch up on, people turning in stuff. So I'm not gonna give another assignment today. We'll do the assignment tomorrow for classwork. So given the cosine of theta is 19/20 and theta is located in quadrant 1, find the tangent of theta. y'all get what I got? Okay. Now, also be careful because like in this example, the square root of 39, that I did a little factor tree in my notes and the only factors were 13 and 3. But remember, if it has a perfect square in it, besides 1, you got to simplify it. And that would be important because you might be able to reduce something. But in this case, 39 has no perfect factors other than 1. So you couldn't simplify it any further. But if you could, you would need to make sure you did that. Okay. And so my tangent, and I know tangent is positive in the first quarter because it's always going to be positive divided by positive, right? In the first quarter, and that's my answer. So I found my sine first before I could find the tangent. Anybody have questions about that? Anybody at home have questions? If not, you may sign off once you are finished with the notes.